Today I'm going to help students answer a question out of the McGraw-Hill-Ryerson Calculus and Vectors Grade 12 textbook. The question is located on page 164. The question number is 13. The question states, a section of roller coaster is in the shape of f of x equals negative x cubed minus 2x squared plus x plus 15, where x is between negative 2 and 2. Question A states, find all local extrema and explain what portions of the roller coaster they represent. Now we will highlight key information of this question. The key information in this question is the function itself, the domain of x, as we can ignore any x values outside this domain. We're looking for all local extrema and what these local extrema represent. At the local extrema, or local minimum and maximum, f prime of x is equivalent to 0. Therefore, the first step to answer this question is to derive the function above. To derive the function, you must multiply the exponent by the leading coefficient in front of the variable and decrement the exponent. Therefore, f prime of x equals negative 3x squared minus 4x plus 1. Now we must find the roots of the derivative, since we know the derivative at all local extrema is equivalent to 0. To find the roots, we must use quadratic formula. We are left with two answers, where x equals approximately negative 1.55 and x equals approximately 0.22. These are both valid answers as they both are within our domain. Now we need to find the y values that correspond with these x values. In order to do that, we need to plug these x values back into the original equation. So once we do that, we're left with two answers. One larger than the other. This will be the maximum. The other smaller one will be the local minimum. Therefore, the local maximum, or the top of the hill, occurs at 0.22, 15.11, and the local minimum, bottom of the hill, occurs at negative 1.55, 12.37. Another way to classify local extrema is to use second derivative test. The second derivative test is used to determine concavity of the local extrema. If the answer is positive, this means that the point is concave up. Therefore, it's a local minimum. If the answer is negative, then the point is concave down. Therefore, local maximum. Now we need to get the second derivative equation by deriving the first derivative of the function by following the same rules as before. We multiply the leading coefficient by the exponent and decrement the exponent. The second derivative equation is f double prime of x equals negative 6x minus 4. Next we plug in the x values into the second derivative equation and see what we get. When we plug in 0.22, we get a negative answer. This means that the concavity is concave down. Therefore, this is a maximum. When we plug in negative 1.55, we get a positive answer. This means the concavity is concave up. Therefore, this is a minimum. Now part B. Is the highest point of the section of the ride at the beginning, the end, or neither? This question is asking at what point along the section is the roller coaster at its highest point, or when the y value is the greatest. This domain gives us the x values which correspond to the beginning, negative 2, and end, 2. So now we need to plug in these x values into the original equation to find the corresponding y values, and then compare these corresponding y values to the y value of the local max. If one is greater, then that point is the highest point the roller coaster reached. If not, then the local max is the highest point the roller coaster reached. We plug 2 into the original equation and get 1. Therefore, it's not at the end. We plug negative 2 into the original equation and get 13. Therefore, it's not at the beginning. Therefore, the highest point of this section is located neither at the beginning or end. It is located at the local maximum determined in Part A. I hope that this video helps clear up any confusion with this question.